an introductory course. So there will be some advanced things, but it's not so advanced. But before I go on, I want to ask if anyone has done anything with Docker or Kubernetes and what you used it for. If you have some experience with Docker and Kubernetes. Anyone? Anyone? So no one. Okay. So as I said, it's an introductory course, and these are the resources I use for the course in case you want more understanding or more experience with Docker. The first two links are the documentation for Docker, and the next link is also for Docker. So if you prefer watching videos, like you understand more with videos, the short courses, Tech World with Nana. The first one is for Docker, the next one is a complete course for Kubernetes. She does a very great job of explaining Docker and Kubernetes. And if you want a full course, a complete full course, though it's not free, it's like 4,000 naira, like $10. Full course on Docker and Kubernetes, you can see the links there. So you will have this in your slide when the slides are given to you. So then the code examples we use for this course, these are the last two links. So we have a small web application that we're using for practice, both with Docker and Kubernetes. So the code examples, though I modified it a bit and it's a bit old, so I added some new things to it. So, but for the main code, you can get it on GitHub with these two links. So this is the outline that I'm using. So we start with containers, the importance, what Docker is, the commands, Docker commands. Please, were you guys able to install Docker? I know the links were sent last week because it takes a bit of time to install. Does anyone currently do not have Docker or Kubernetes, Docker desktop? Okay. Okay, please just collect the setup so that you can follow with the practicals when we start. So we move to building Docker images, Docker networks, Docker Compose, and a simple real-world project with Docker Compose. So the link to practical, I've uploaded the practicals for this course on GitHub. So this is the link to it, https://github.com/kubregroup/hpc docker k8s. So I think maybe I can just say that now. So when you see K8s, it's not an acronym, it's a short form of Kubernetes. K for the first letter in Kubernetes. Then the letters between K and S, the last S, are all 8 characters, and S for the last character. So that's the short form for Kubernetes. So please get this link down. You see all the practicals we use for today. So before I start, I want to make this class quite interactive. I would like to ask a question. What is a container? You can use analogy from any part of life. And I want definition from 3 different people what a container is. Anyone can try. Container. If nobody raises his hand, I will just come to you and give you the mic. No English, please. Yes, just give the mic to anybody. Okay, thank you.
I can say container is like a virtual environment.
No, just analogy in real life, not the actual software.
In real life.
Yes, what you feel a container is.
In real life.
Yeah.
Container is just like a box or a building.
Okay.
In which we have person like our workshops hall is like container.
Okay. Thank you very much. So I think we can pick something from that. He said a container is a box or a building where we have people in. Let's just put our mind on a box. Okay.
Container is like a confined space
Okay.
that is carved out to hold specifics.
Yeah, thank you very much. We can pick two things from that: a confined space carved out to hold specific things. So a box, a confined space, and it's carved out to hold specifics. Any more person? Okay, thank you.
Okay, a container is a vessel or a receptacle that is used to hold anything, really.
Yeah, a vessel that used to hold anything. So I think thank you very much for that explanation. A box, a confined space, a vessel, a what do you call it again? A vessel. A vessel that is carved out to hold specific things, and we can just relate that to software, software containers. So, but I have my own analogy here. So we can see house container here. The specific things we can notice about this is that it's a box. It's an isolated space, and it's built to house someone. Everything you need to live a normal life is in it. It's confined, is isolated. So we can use that as an analogy in software containers, but I will get to that. So this house gives an analogy of a software container. It contains everything a person needs to live comfortably. Everything and its dependencies, all the dependencies: a bedroom, a living room, a bathroom, a kitchen. You can see the kitchen. For you to live at least a normal life, you don't need to go outside to get maybe to bath. You don't need to set up firewood to cook outside. Everything is all confined in the house container. It can be moved. Yeah, that's one specific thing. Okay, I think you said a vessel that can be transported, right? Yeah, okay. So it can be moved, shared as a complete unit, and no need to reach out to get something you need to live a comfortable life. So, in software world, containerization is a lightweight alternative to a full machine virtualization. It involves encapsulating an application. Let's say you want to have an application to do something. It encapsulates it in a container, and it houses its own operating environment and a good point, and all its dependencies. Everything the application need, it's all encapsulated in a virtual container, and houses its own environment and all its dependencies. So containers are mainly layers of stacked images. Because, for example, we have here, this is the base image. So then all that layers of software are stacked on top of it. So I've mentioned the base image. All other dependencies are built that is needed for the application. Like you see, this is a server, a database server. All the things you need are all stacked upon it. Containers are expected to yield the same result no matter where they run. So one another good thing of containers is it can be transported. It can easily be shipped from one position, from one operating system to another operating system. So containers are mainly applications, are mainly isolated environments that contains an application. It has all these dependencies stored, and it has its own operating environment. So let's ask the question: what is the importance of containers? Why do we want isolated, self-sufficient application packages? So for example, this is in the software engineering world. Let's say you have an application, you are developing it, probably you are using Python 2.7 on your personal machine, but you want the same environment in the production and test environment. But funny enough, in the production environment, you have Python 3. So by the time you try to ship it to a newer environment, you start getting errors, different errors, because your application is not compatible with Python 3. But container here can help us solve this problem because it's all packaged. It's an isolated environment. It's all packaged. It's just like a container you are using to ship goods from one country to another. It's all packaged. Everything you need is all encapsulated, isolated into one environment. So with containers, we can easily have the same environment in development, production, and test environment. And also, when you are working as a software engineer in different teams, you want the same environment, you want the same code base in the different environments. Also, for a single developer, let's say you are working on multiple projects. First project, maybe to build, maybe to program an ATM machine. And for that project, you need probably Node.js. Node.js is a JavaScript runtime. You need Node.js 12. But also now you are working on another project. But this one you need probably Node.js, the very latest version, probably to use some new features that have been included. But this is very hard because let's say you installed Node.js 12 on your system. Now you have to uninstall, remove it, then reinstall another latest version. So this kind of give a lot of headaches, but with container, you can easily spin up a container, install Node.js on that container. And when you want another project, you can easily spin up another container. No need to change anything in your base operating system. I don't know if I'm communicating or if there is anything unclear, if I can go on. Okay, thank you. So I'm sure some of you must have been thinking, what is the difference between virtual machines and containers? So we have this. So now we can see a virtual machine here. So these are the infrastructure, your CPU, your RAM, in form of a laptop, a server, a cloud. Then for virtual machines, you have an hypervisor. It can be a software, firmware, hardware, and it's mainly used to spin up virtual machines. So you can see it has spinned up several guest OSs, different OSs. And now you now have applications on it, Linux applications. You can see the different applications, but one thing to note, it's a full OS, a full operating system. OS 1, OS 2, OS 3. The three of them, funny enough, are Linux. One could have been Windows. But for containers now, same thing. You have your infrastructure, you have your operating system. This also can be an operating system, but here you have a container engine, which can be Docker, Containerd, and Cryo. Then you now have your application, so you can easily spin up different applications. From this, you can see that for virtual machines, you spin up full operating system. Though they also are container. They have their own isolated space. They are all isolated, but you have full operating system. But for containers, you just have one operating system, and you can spin up several containers as you want. So VMs and containers both help to spin up independent, isolated environments. That's where they share similarities. So let's say you have two projects. The first one uses Python 2.7 and the next one uses Python 3. You can install Python 2.7 in the first guest OS. And if you have a very strong system, you can spin up another OS and install Python 3.2 or whatever in another OS. Same thing you can do with containers. In the first container, you can spin up Python 2. In the next one, you can spin up Python 3. So virtual machines and containers help to spin up independent and isolated operating environments. Okay. We are getting to that now. Yeah. So containers are lightweight. That's one key difference. I use lightweight operating environments compared to virtual machines. I know when you are spinning up a virtual machine, you have to dedicate the number of CPUs you can use, dedicate the number of hardware storage you can use, dedicate number of RAM. So let's say the virtual machine is not using the resource at the moment, so that resource is just there, lying to waste, nothing happening. But in a container, you just spin it up, you use it, it gets its job done, and you can completely remove it. It can easily be created and destroyed. That's one good thing, one key difference. Virtual machines, you have to dedicate the space, but container, you can easily spin them up. They're lightweight. So allocation of resources is not also optimized in VM, as I've explained. Containers can easily be built, shared, and executed in different environments. I can suddenly decide to install my container on a cloud in Germany, AWS in Germany, or in US easily. But if you want to move a virtual machine, you're moving a full operating system, and it's going to give you a lot of headache. For example, in this course we are taking, bioinformatics course, so the host installed all the tools we needed for the course, everything in a virtual machine, and decided to transport it to everybody all over Africa. It gave a lot of headache. Even till now, some people were not able to get it working because different architecture of hardware. So not everybody could get it to work. But with container, that won't be possible. It's very easy. You can easily transport your container here from the comfort of your laptop to Taiwan or to any country, in as much it has the normal infrastructure you could use. So containers can easily be shared, executed in different environments. But with virtual machines, sharing is very, it can be done, but it's very tricky. So that's the thing. That's the difference. The differences between containers and virtual machines. I don't know if any other person can even add to this point, because I know this is not everything. Does anyone also have points? Difference between virtual machines and containers, and would like to share? Okay, none. So we move forward. So what is Docker? So Docker is a container-based technology. So it's for building, creating, manipulating, orchestrating, executing containers. Docker provides the ability to package and run an application in a loosely isolated environment called a container. Docker makes deployment of application very fast and easy because you can easily transport containers from your laptop to any high-performance computing system. And it aids continuous integration and continuous deployment workflows. This is a term used in software engineering where you have multiple people working on a project, and you can easily deploy. Continuous deployment means you can easily deploy each of the application in stages. So Docker makes application very highly portable, because containers are highly portable, and you can easily set it up on your local machine or virtual machines in a Docker, in a data center. So here I tried to give an architecture of Docker. So Docker uses a client and server architecture. Client means you have a host somewhere or user somewhere, and server like in a centralized location. You can easily connect, everyone can easily connect to the server. So Docker client is the primary way the users communicate with the Docker daemon. And this is done via REST API. I don't know if computer scientists, software engineers know what REST API is. Mainly this is sending data via JSON format. So the Docker daemon, which we talk about here, does the actual work of creating. You can see it here. That is the client. This is the server, the Docker host. It does the actual work of executing, of creating, running, executing, and distributing the Docker container. So when you submit a command, as we'll be doing later, Docker build, you send it out, you send it via JSON to the Docker daemon, and it does the actual work. Okay.
When you say the Docker client, is it the system administrator who is going to use Docker, or is it user who the administrator is making the service for?
Okay. Docker client is just the actual Docker application on your system.
Okay.
So anybody can use it. The administrator,
Okay.
the
Docker
user.
client is the
Yeah, the
daemon
tool.
running on your computer.
No, you have a daemon running the
Okay.
server. For some systems, like if you install Docker Desktop, you have both the client and server. So when you submit Docker build, you have a Docker. That Docker, it's the client submitting an instruction of build to the daemon. So that's the job of the client.
Okay. So
Okay.
is two services running in the?
Yeah.
Oh.
Okay, please come again with your question. Maybe I didn't.
When I'm using Docker, I don't have two daemon running on my computer. I just have one daemon.
And you know, the way the Docker does it, you don't interfere, you don't directly interact with it. You submit commands to it via Docker. So when you run Docker, this is something that happens behind the scenes. It's like a black box. You don't see it. When you run Docker build this, it submits the command to the daemon running as a background process running in your system. So the Docker is the client. The client, it can be on your system, it can be on a server, because there are ways you can do the connection. Also with Kubernetes.
You can submit an Docker file to another Docker on
Another Docker
remote
server.
machine.
Yeah, but you know you have to specify some host in the configuration settings.
Okay. Thank you. Yeah, good.
Okay. So next we have the registry. So this is where every Docker images are stored, and the command registry is Docker Hub. I don't know if anyone has used Docker Hub before. Docker Hub. So it's like an online repository where several images are stored. So when you want to like create your own Docker image, you specify base images. These base images are collected from the repository called Docker Hub. So now I'm mentioning images. What are images? Docker images are templates with instructions for creating Docker container. So it's just like a building and the blueprints for the building, which architectures create. The architectures define the specification for a building, the room size, where the toilet should be, how many stories, and everything. So this is the same thing that Docker images does. It specifies the instruction with which you will use to create the container. So containers are the actual runnable instance of the image. So we have examples of Docker images. Okay, we'll get to that later. So these are the installation commands. I think we've all done this before. So now we move to the main Docker commands. So for container management, that's for creating, executing. The first one we have Docker pull image. So Docker pull, this allows us, I mentioned something about a Docker repository, and this mainly contains, this is an online repository that contains a lot of images that have been used by several people. We have an image for Ubuntu, we have an image for Python, we have an image for MongoDB, which are databases. So in case we want one of those images on our system, we can use the command Docker pull. So it goes to the online repository and pulls the image for us. Yeah, that's Docker Hub. So when we want to execute the image, so we use the command Docker run image, and if you have a startup command, we include that thing. This Docker run, in case you want to run it in detached mode, run it in the background. So we use Docker run. So in case you want to give it a specific name, the container, there's a mistake here. This should be before the RM. So you just want to give the container a name, we use chosen name. RM means when you stop the container, immediately delete it. So RM removes the container. The chosen name is the name of the container. So if you want to start it in interactive mode, all these commands, we will try it later in the first practical session. So this is already in the GitHub repository. So -it means run it in interactive mode. Let's attach it to a terminal, the bash terminal. So it also create and start it. We'll be trying this. Alpine is a name of image It's a very lightweight Ubuntu image with a lot of things stripped off of it. So we have other container management commands: Docker start container, Docker start a container to output more information, stop a container gracefully, not forcefully. We use Docker stop container, Docker kill container, Docker restart container in case you stop it without the RM argument, Docker pause container, and if you want to forcefully destroy a container, use Docker RM-F container. So we'll be trying this very soon with different images in Docker Hub. So if you want to interact and debug with a container, with a Docker container, so Docker PS list all the running containers. Let's say you started the container and list everything. Docker PSA list all containers, both running and stopped. Docker images list all the images you have in the system, because you have to first pull the image on your system before you run it. So it lists all the images you have on your system. Docker logs, it lists all, in case you've started the container in a detached mode, that means in the background, and you want to see the logs of the container, use Docker logs. Top container lists all the running processes of a container. You know, in an Ubuntu system, you can type in top and to list all the running processes. Docker top container also lists the processes in a running container. This shows the differences between the image and container. It shows low-level infos in JSON format for the container. And this is a very useful one. In case you want to execute a command in a container, you use the docker exec command. And for example, okay, I don't show it here. Okay, so this is an example. Let's say I'm running a Redis image and I want to spin up the Redis CLI. I can use docker exec. This is run in interactive mode. I need to spin up a terminal with the Redis CLI. Yeah, this clears, in case you are done with the container and you want to clear it, you can use docker container prune. This deletes all images you have on your system, and this deletes all stopped and running containers. So I think it's time for us to try some things, or a few of these commands. So in the link I shared earlier, so I included some commands that we can try our hands on. So I would like us to try these commands together before we move forward. Is it okay? Oh, yes. Okay, let me go back. So this is it. Please, how many people don't have Docker on their system? Please try and install it. Try and install Docker Desktop so we can practice. Okay, I said don't have. Sorry. Okay. So this is the link. This is the link to the practicals.
So I want to know if it can be possible to use an image without a container.
Thank you very much for the question. So as I said before, the image is what you use to build the container. The image specifies the configuration, the specification for the container. So we'll go to several examples of images, but let's say I want a PHP, I have a PHP application, and I want it to be on a Ubuntu operating system. I specify the base image as Ubuntu, and I try to install the dependencies my application needs. So the process of specifying all those things, I'm creating the image. Then when I create the image and I want to start the image, the starting of it, the running of it is what produces the container. So the image specifies the blueprint, the template for creating the container. So image is the template, container is the actual running instance of the image. I don't know if, okay. Thank you very much. So has everyone gotten this link? Thank you. So it would be good if we try these commands. So I will share my system now, the screen of my system. Um, can you see my screen? Is it big enough? Um, Yes, we'll try it on our system, but I'll try it also. Yes. will get to Kubernetes. Yeah, after Docker. Yes. No, I'm trying to increase this font size. No, this is a text editor, a code editor. Please, how many people were able to install VS Code or has VS Code installed? So VS Code is a code editor. So you can have a text editor and a terminal joined together. Yes, I included it in the list. Huh? Please come. How? No, this is not fine. This is a code editor. I have to increase the font size, but it's not working. I know. I say install VS Code. Yeah, I've set it up. Is it clearer now? Can you see? Okay. So, the first command we are trying. So please, we can try this. Let's check if you have Docker installed. So you can use VS Code. Okay. fẹ́ sọ nìyẹn. Tẹ́ bá ní VS Code. But if you don't have VS Code, you can just open.
Let me install VS Code.
But you already have Docker desktop. You see?
We start to install VS Code.
Yes, install VS Code. But you already have Docker desktop. Okay, no problem. Please, how many people have VS Code? It's a code editor. No, okay. So you need okay, the reason why I'm saying you should install VS Code because it has a code editor and a terminal attached to it all in one. So if you can try to install it, please do. Else you can open PowerShell or command prompt. Both will also work, but you lose the added advantage of the code editor. So if you can try to install it soon, please try. So if you don't have, probably when I move to the next theory section, you can install it in that period. But now please try to open a terminal. Your Windows terminal or PowerShell terminal. Please try to open that. Please note you must have Docker desktop or a Docker toolbox installed before you can try these commands, because the first command is to check if you have Docker installed. So I am using PowerShell. PowerShell is also good. If you have a Mac, you can use your terminal, but ensure you have Docker installed. So the first command to try is docker-version. Please try that command. So I am trying that now. Oh, sorry, it's double dash. Oh. Okay, is the character. Oh, sorry. So this is it, a dash version. I think I should type it. Okay, let's use the short form. So I have Docker installed. Okay. Version 20. Yeah, thank you. No, just you can leave this one. Just focus on terminal. Your terminal. Okay, PowerShell. Yes. So please, what version did you get? 19. Okay, good. We sent the link to install it last week. Yeah. So just type Docker in V. Check if it's installed. Some problems. Okay, but you need to practice. So please, to practice, in case you don't have, we aren't able to install uh, Docker Desktop or Docker Toolbox, there is a playground, this link, so you can practice. So it gives you 4 hours to play with Docker. So you can also run these commands if you don't currently have. Okay, it's too small. Um, yes, okay. So this is for people who weren't able to install Docker. So please visit this link, https column / labs.play with docker.com. So this gives you 4 hours to play with Docker. So this first practical section, you can use this web application. But during the next theoretical session, please try to install Docker Desktop or Docker Toolbox. But for now, we can use this web application. https colon / labs.play with docker.com. This gives you 4 hours to play with Docker. So this is for those who were not able to install Docker. Have you gotten the link? Can I change it? And please let's respond. Okay. So for those who are not able to install Docker, please try this command docker-v on your playground. So this is the link again. Yes, yes, it is. So for those who are not able to install Docker, please use this playground. So in the next theory session, you can try to install Docker in that period. So let's move to the next command. Okay. So please, who had problems with Docker? Problems, challenges, problems, challenges. So can we go on? Were you able to get it to work? So please, let's move on. So the next command is docker info. So this gets information about Docker and your system. So please, let's try the command. This is just to ensure that, okay, Docker is up and running. So this shows information about your system, the client, the server, the number of containers running, stopped containers. It shows all the basic information you need about the Docker client and server. So at least if you're able to run these two commands, it means Docker is up and running on your system, and we can start the actual practical. So the first command we try is docker pull. So this pulls an image from the repository. As you recall, I said the repository is where you have a lot of Docker images built by different people. Have images for Ubuntu, for MongoDB, for web servers like NGINX, for different things, for Python. You have a question? Okay. For different things. So now we want to pull Ubuntu image and run it as a container on our system. So docker pull gets the image from the Docker repository. I think I should open the repository so you can see what it looks like. So this is the Docker repository. I can search for images. Let me search for Ubuntu, the image we are about to pull. So this is the Ubuntu image. So you can see the command here, copy and paste this command to pull this image on your system. So these are the different versions that are available, matched with tags. If you want a specific version, you can choose Ubuntu 18, 20, 20.10, different versions. So the tags are the versions. This is more information about the Ubuntu image. If you want more information about how to run the image, you can visit this page. So this is the official Docker Ubuntu image. There are so many images you can get from this site to use as base image for your Docker file. Let's try NGINX. So NGINX is a web server for serving files. So in case you want to use this, this is NGINX. We can try databases too. Let's try MongoDB. Or just Mongo. Okay, no. This is for my system. Oh, okay. Give me one moment, please. Okay. Okay. So this contains a lot of images you can use. So now we want to pull Docker image, Ubuntu image on our systems. So the command to do that is docker pull Ubuntu. So this goes to Docker Hub, as I've just shown you, and pulls the image on our system. So you can see it's using the latest tag. That's the latest version. I think I already have the image on my system, so we didn't need to download it. But please, try the command. So please, let's pull Ubuntu image on our systems. So please, who was successful pulling the image, Ubuntu image? Please kindly raise up your hands. Thank you. If you have challenges, any challenges? Any challenge? Okay. Have you started? please, if you're having error that Docker daemon is not running, daemon is the server of the of Docker. Please try to go back to the installation guide and check if you omitted an installation step. It's very important, please. Because if the daemon is not working, which is the server, you cannot run any Docker command. The daemon is what does the actual work. So I'll be moving ahead. So for those who still have issues, you can try the playground for now. And probably during the next theoretical session, you can try to resolve the issue. Just try the playground for now. Yes. Let me open the link again. Okay. Can you hear me, Shane? Yes. You have to sign up. For the playground, you have to sign up. So for those who were able to pull the image, you can check the image if the image was successfully pulled on your system with the command docker images. So for me, these are the images I have. Let me look for Ubuntu. So these are the images I have on my system. So to recall, images are the template which we use to create the containers. They are the instruction which Docker daemon used to create the containers. And containers are the running instance. And this thing be bigger. Okay. Okay, you can see it. You can see it here. So this is the container ID. The number of days I've pulled it, the size, the name, the image name, and the image tag. So I want to use this opportunity to explain something. So since Ubuntu is used a lot for a lot of applications, web servers and the rest, web applications, you can see the size is 315 MB, very large. So there's an alternative, a very lightweight alternative to Ubuntu. It's also Ubuntu, but a lot of features have been stripped out, leaving the very, very essential features, and that is Alpine. So you can see the size of Alpine, 72 MB. So most applications, they prefer to use Alpine because of the smaller size. So it's very easy to install it. You said? Okay. So the Alpine is always smaller than the Ubuntu image. Ubuntu is much more larger. Alpine is smaller. So now that we have the image, the next thing is to run it. Before I go on, does anyone have issues? Okay. Okay. And type docker -v to see if -v. Yes. So it's installed. Okay, you two have it installed. No, it's not typing. Yes. No, there has to be a space. Yes. Yes. So after we pull the image, the next thing is to run the image. Please know the syntax of it. Docker, the Docker client, the command, some arguments, and the image that we want to run. So I just ran the image, and we can see we have an Ubuntu on terminal prompt. Please let's all run the command docker run -it ubuntu to pull the image number. You need to have, you can have an account. Yes. Yeah. But you have to sign it first. When this is signing, you go to their website or to create an account. Docker run. Docker.docker.com. No, no F. Please, who else was able to successfully run the image? Thank you. Okay, thank you. You can try the playground. So we have a full Ubuntu system running currently. So we can try, even though this is like a Ubuntu image, it still doesn't contain a full-blown Ubuntu version. It's still stripped down. So commands are not working. But we can try some commands we learned in the first day. Let's try to create a text file with cat and include like 5 lines into the file with this Docker container. Let's try to create a text file with cat. You can just try to make 5 lines in the text file just to test the container. So I'm going to try my own now. So I just created my own file in the container. I can list the contents of the folder and I can see the new file I created. Test.txt. I can view its contents. So this is a container, Ubuntu container, and we can try all different kinds of commands in the Ubuntu container. But this is not how we use Ubuntu containers. We use them as a base image to install applications. So let's say I have a front-end application, probably in JavaScript or in a framework like Angular. I could use Ubuntu or the stripped down version Alpine as a base image, install all the dependencies I need, create the startup command, then run the container. These are the ways we use the Ubuntu images. So we can try other commands. We can list the contents of the folder. Yeah, Docker pull grabs the image from the repository, Docker Hub, to your machine, to the local machine. So we can try several commands. So in a new tab, we can list the all running containers with Docker PS. I think for me, I have so you can see the running container, the container ID, the image, which is Ubuntu, the startup command when it was created, and the given name, the given and container name. This name is automatically given by Docker. So let's say I close. I close the container and I want to see all running and exited container. I can use Docker. Any questions? Okay, no questions. Docker PS. Yeah, okay.
Yeah. So I noticed that when you run that IT Ubuntu, it creates a new one every time. So if we want to go back to that, like I ran it twice, so it created these two. So if you want to go back to this particular one, how do I do that?
Okay, you get the container ID
Okay.
and you start it or restart.
Okay.
Use restart. I showed the command in my slide.
Okay. Okay.
Restart.
Okay.
But first check if it's still running. Okay, let me. So in case you exit a container and you want to restart it, first type docker ps-a. Okay. So first type docker ps-a to get the container ID and restart it. I will show the command for restarting now. I think I have it. Okay. Or you can just use start. Start with the container ID. So this should be the container ID. Or F-A to upload more information. Yes, run. Run -t or -it. Okay, this is a practical. So now that you've run the Ubuntu image, the next thing is to try several commands on it. So I said you could try creating a text file with 5 lines with cat. A text file. Yeah, any name. You can give it test.txt. Yes. What you do in Ubuntu. Though this is not a full Ubuntu system with all the power features of Ubuntu operating system, but what you need is available. So you can create a text file. For example, Nano is not included in this Ubuntu image, so you use cat. You can use cat. Okay, let me show it. So in case you stop a container and you want to start it again, you can use the docker start with the container name. But if you have a running container and you want to have a terminal into the container, there's a different command for that. Use the docker exec command. So let me show it to you. So I have it under interacting and debugging containers. So if you have a running command, a running container, you can use docker exec -it, the container ID, and the command you want to run. In this case, you want a terminal, so you use sh. So this gives you a terminal access into the container. Please try it out and tell me the results. Okay, no such file or directory. No, when when you use cat without the greater than symbol, it views the content of the file. But you use cat to yes, then greater than yes, then the name of the file. You can add a .txt. Do yes, just know it's a text file. It's working. Thank you. So in case you start a container in detach mode and you want to view the logs of the file, you can use this command, docker logs container ID. So later in the real world practical sessions, you'll be running some containers in detach mode. So we can use, you might want to view the logs. You can use docker logs with the container ID. Okay. So to create, I said IPAN is a stripped down version of Ubuntu. So in case I want to have it a starting command rather than the default command. So sh means start a terminal based on the Alpine image. So run docker image with a name. This is the chosen name. This arrow means when I stop the container, automatically delete it. And this is the stripped down Ubuntu image. So this is what my gentleman asked. So if I want to have an access into a running container, I use the exec IT. So bash or sh, these are the commands that will start a terminal. So to stop a container, you use the docker stop container ID. To kill a container. But I want us to try these commands on our own. Stop will gracefully stop it. Kill will destroy it. Yes. Um, I think it's time for lunch break. Or tea break, sorry. Sorry. Tea break, I mean. And they are ready for you guys, so please kindly go downstairs. Control C. So tea break is for 15 minutes. So we'll be back in 11:10.